Okay guys, let's continue. Now we're doing 6.8. Same instructions. Draw a shear force diagram, bending moment, find maximum shear force. Last time on the last video we didn't find maximum shear. The maximum is just simple. The maximum shear force for this one is minus 10 kilonewton. Why? Because this is the largest force here. This is 2. And then the maximum bending moment, it's minus 11 kilonewton meters. Why? Because this is the largest here. Remember, this is minus 8. So on the last video we didn't say that, but here. Okay, let's continue. Right, so again we need to draw a shear force diagram. So here now we have a UDL, but relax. So again we're going to start with force at A. Right, let's look at force at A. So at A, this is where the UDL starts. So the UDL starts at A and end at B, right? So remember, UDL, it's kilonewton meters. So we need to convert this into a force. How do we convert? We just multiply by meters. So whatever distance, we multiply it. So for example, let's look at it. What is the force at A? Remember, downward, down is negative, up is positive. So we have 5 minus 5 because it's going down, kilonewton meters per meter. This is ADL. What is the distance when you are starting from here? What is the distance at A? Times 0, which is equal to minus 5, equal to 0, I mean. So yeah, this is 0. Force at, remember again, force before B, force before B, force before B. So this is initial always. So the force before B is what? So you include everything before B. So it's gonna be minus 5 times whatever distance, which is 4, times 4. Remember, this is a UDL, kilonewtons meter, times 5. This is the force. So before B, before you reach B, there's this force, which is 20, I think. So it's minus 20 kilonewton. Then force is at B. Force at B. What is the force at B? So So force at B is what? 65. So it's gonna be the previous one, which is minus 20 plus 65. So minus 20 plus 65, it's what? 45, positive 45 kilonewtons. Remember, this one is just the force, right? So then we have force at C, before C. So what is the force before C? You already have 45. There's no other force in between B and C, so it's gonna just be 45 kilonewtons. And then at C, so then we reach C, we have 45, then we have minus 20, and then after minus 20, remember the UDL also starts here. 5 times 0 minus 5 times 0, which is equal to, it's just 45 minus 20, which is 25 kilonewton. Then force before D, already we have 25, right? Remember, but now before D we already have 25 here, and then we accumulated the UDL, so it's gonna be 25 minus 5. Remember, UDL is what you need to times by distance times 5 times 2. Why times 2? Because the distance between C and D. Remember, we're starting at C. 25 is at C. So before D we have this 25 minus 10, which is 15. Let's double checking. Kilonewton. Then at D, forces at D. So already we have 15 before, then 15, and then we need to minus this reaction at D. You cut to 0. So the reaction at D, it's minus 15 kilonewton. So this reaction is minus 15 kilonewton. Then we are done. Now we draw. So we have A. This is not B. B here. C and D. And then again with green. So now let's check. Forces at A, it's 0. Then forces at before B, before B is minus 20. So you go first to B and then minus 20. Then again at B, so BP, it just means we are at B. Then B, we move to 45, which is up here. Positive, remember. This is a negative side, this is a positive side. Then C, before C, we still have 45. So again, we have 45. And then at C, we move down to 25. 25 is somewhere here. Then before D, we have 15. So we're gonna move down to 15. And then we go to 0. So let's now join. So we have A. Remember, there's a UDL. Just join the point. So we go from here, from 0 to minus 20. 0 to minus 20, which is this. And then we go up to 45. And then we go straight to 45. And then we go down to 25. Yeah, we go down to 25. And then at D, the initial one, it's what? 15. We go from 25 to 15. And then we go down. Right? So then you write. So this is a shear force diagram. Unit kilonewton. We have something like this. Now let's do moment. So moment, bending moment. So moment at A. So at A we have what? So we have minus 5, which is UDL, times distance to make it a force, which is 0, obvious, from A. Then times the distance times 0 again, which is just 0. Moment at B. So there's B here, right? So we have the UDL only, so we have minus 5. What is the distance from A to B? It's 4 times 4. We converted this into a force, and then that force acts in the center, so center of that distance. So this is a UDL times the distance between A and B times always times half of that distance. Always the UDL is always going to be this. The total distance times half of that distance where the UDL lies, which is equal to minus 4 times 4 times 2 minus 40. Then moment at C. So moment at C, we have only the UDL at A to B plus the distance here. So it's going to be again minus 5 times 4. The UDL ends at 4. Not because now we are going to see, we need to say times 6. No. The UDL, first convert the UDL into a force. The UDL ends at 4. You don't have to stretch it. Times in bracket now, because it's no longer limited here, we are going to C, we are not going to B. So times 4 over 2, because that force acts in the middle here, then plus this distance 2, right? And then we have another force plus 65 times 2, then the answer. So it's gonna be minus 5 times 4 into 2 plus 2 plus 65 times 2, which is 50. Then moment at D, we need to calculate it also. So again, the UDL still minus 5 times 4 into that distance over 2 plus whatever distance that is left. So after the UDL we have 4 again plus 4 this time. So we have something like this, minus 5 going down. The UDL ends at this distance from A to B, that's why it's times 4. And then we convert it into a force, and that force acts at the center of that UDL, which is 4 over 2. But now we are not going to B, we are going to C. We are going to D, so it's going to be plus 4. Why? Because from distance from here to here it's 4, and then from the center it's 2, so it's plus 6. You can even see 6. And then now we are going to D. We still have 64, so plus 65 times 4 minus 20 times 2. We also have 5, so this time 5, the UDL is at the distance of 2, so it's gonna be minus 5 times 2 in bracket 2 over the distance. We are within the UDL, so it's fine, there's nothing we can add. Then we have something like this. So now let's calculate. So it's minus 5 times 4 into 6 plus 65 times 4 minus 20 times 2 minus 5 times 2 times 1 equal to 90 kilonewton meters. Then now we need to draw. Let's draw the blue one. So moment at A is 0, then this is B, then C and D. So moment at A is 0, moment at B it's minus 40, so minus 40 somewhere here. Moment at C it's 50, positive 50. So it's somewhere here. Then moment at D is 90. 90 is somewhere here. So now we have a UTL. Now, every time we have a UTL, we need a circle of life. So we have something like this, and then you draw 1, 2, 3, 4. 1, 3, 4, 2. Right. This is 0. This is positive. This is negative. It does not matter. So we have something like this. This is a hack. Every time you have a UTL in your graph. So you check. This is a shear force. This is a bending. So you check. You see, yes, we have A up until B, which is a straight line, and you check it's negative. So it's below 0. This is a 0 line. This is a 0 line. So here, 4, number 4 represent A to B because it's below 0. So it's this one. So where is 4 here? 4 is here. You see? Then you draw. You start from here to here. So where it starts, so we're gonna curve like this because we want to draw this curve. So it's like this curve. 4 up until 40, and then there's no, between B and C there's no UTL. You just join this, they run straight line. And then let's check at 25. We have this one, which is number 1 because it's above 0. So this is number 1. Then number 1 is like this, so it's gonna be curving like this up until 90. Do you see? Then you go to 0. Remember, so this empty, if this one we calculated is 90, that means this one is minus 90 kilonewtons because it's the one that's gonna maintain the equilibrium. So we have something like this. This is your graph. This is our curve. Then here the maximum shear force is just 45 kilonewton. Then the maximum bending, it's 90 kilonewton meters, right? Then we have PC, point of contact flexure. So the point of, we have a point of flexure here. Remember when you, so it's between B and C, right? Here's what you want to do. Every time you're calculating the point of contact flexure, the first thing you do, you identify where it is. So it's between A and B. Then you always go to the original graph. So the point of contact flexure is here. And then you call that point, whatever point. We can say this is E because D is already used. Right? Then we choose. It's easy to come from A to B to E. Then you calculate the bending moment at that point. Let's just calculate it here. Point of contact flexure. So bending moment at E. So we call this point E. Then you calculate bending moment at E coming from A. So it's gonna be what? Minus 5, right, times 4, the UDN, now it's a force, then times the distance. So it's gonna be 4 over 2. Because now we are going to E, we don't know this distance. Yeah, we don't know this distance from B to E, so we can call it X, right? Not the whole distance, the distance from here to here. Don't say from here to here it's X. You are making your life hard. Just say from B to E is X, right? So it's gonna be 4 over 2 plus X, right? Close the bracket. And then we have another force plus 65 times X. We don't know X, right? Remember, point bending moment at E is what? From the graph, it's 0. It's equal to 0. Then we solve for X. So it's gonna be, let's solve for X now. Minus, so it's gonna be, let's multiply in. So it's gonna be minus 20 times 2. So it's gonna be minus 40 minus 20x plus 65x is equal to 0. 65 minus 20. Then we have 45x is equal to 40. Then x is equal to 40 divided by 45. 0.889 meters, right? So we have something like this. So now we know this x, it's 0.89 basically. Now from the wall to E, so it's gonna be, the total distance is 4 minus 0.89. So 4 minus 0.89, 3.11 meters from the wall. So yeah, so it's gonna be 3.188 meters from the wall. This is our PCF. Let me just confirm it. Right? So on Drotsky, now let's look when we are coming from A. From Drotsky, they say they are coming from A. Where's A? A is here. So from A, we already know this is distance is 4. Then we know from here to here it's what? 0.88. So it's gonna be, from A it's gonna be 4 plus 0.889, which is equal to 4.89 meters from A. So yeah, don't pick from the wall, it's 3.11, which is correct, and then from A, it's correct. If you didn't see it, listen.